Welcome everyone to the AMS Python short course. Normally this is something we do at the AMS annual meeting. Normally it's a workshop on a couple of days prior to the AMS annual meeting, but obviously that didn't happen in person this year, and so we're trying our hand at an online workshop for the first time. So welcome, you got through the first part, you connected successfully. In terms of introductions to, I guess, all the people on your screen, I'm Damien Irving. I'm a postdoc at the University of New South Wales in Australia. And who else have we got? We've got Kathy Pedgion from George Mason University and Sarah Murphy from Washington State University. The three of us will be doing kind of the teaching today and on Thursday, which is the Data Carpentry part of the course. So for those who aren't familiar, Data Carpentry is an organisation where volunteer instructors like myself and Kathy and Sarah basically teach basic programming skills to researchers, and they develop and maintain lesson materials for specific research disciplines. So there's lesson materials for ecologists, for people who work in genomics, astronomy, social sciences, all sorts of stuff, and they have some lessons for atmosphere and ocean science, which is what we'll be using to kind of bed down some basic, I guess, Python skills over the first 2 days. Then we've got Ryan and Drew and Nicole, who's not on the screen but might be here for some of the other sessions from Unidata, and they'll be helping out today, and then they'll be taking the lead next week when we do a deep dive on a Python library called MetPy. Some of you might have used, or you possibly signed up because you're interested in learning more about it. Then we've got Scott Collis there on the screen, who is kind of a lead author on a PyArt, a package for looking at radar data. So we'll be doing a deep dive on that with Scott next week as well. And then we've got Kevin Tile there as well, who is at the University at Albany, and he'll be helping us with Pangeo next week, looking at kind of handling big data and things like that. So that's kind of the helper team that'll be helping everyone out over the course of the workshop. Cool, so that's the technical side of things. In terms of the teaching format for this first 2 days, basically what we'll do is we'll oscillate back and forth between either myself or Kathy or Sarah doing some live coding to demonstrate some kind of new concept. That'll go for 10 or 15 minutes, and then there's some exercises basically that everyone will work on in groups, and we'll split off into breakout groups to do that, and you'll work on some exercises relating to those concepts that we just introduced. There'll be a helper in each of the breakout rooms in case you've got questions, and then once do some more live coding for another new concept, go back and do some exercises relating to that, and so on. So that'll be the basic format, and there's no need to kind of follow along as we're live coding. It's basically just a chance for you to sit back and watch and take in the new concepts that we're explaining, and you'll get an opportunity to try them out during the exercises. And basically what we'll be doing over the course of these first 2 days, if I share my screen here, the precipitation climatology for any kind of CMIP6 model data that we give it. So to skip basically all the way to the end and give you a spoiler, by the end of this, we'll be able to type Python at the command line. We'll have a name, we'll have a script called plot precipitation climatology. I've got the final version here. Then what we'll be able to do is give it the name of a file that we'd like to plot. What have I got here? I've got some data from the Access model, which is an Australian CMIP6 model. I tell it what season I'd like to plot. Let's plot the summer rainfall, and then let's call it test.png. And basically, we'll have written this Python script from scratch that can plot the precipitation climatology for just some arbitrary climate model data file that we give it, and that'll go away and have a think, and hopefully I'll get a picture in a minute. Come on. There we go. Cool. So if I then open that, that's what we'll end up with. a script that's able to do this for any model that we want, and we'll be able to customize it at the command line by adding grid lines and all sorts of other good things. So that's where we're headed, basically. So if I stop sharing my screen. As I'm going along, if you've got any questions, basically just pop them in the chat area, or when Kathy's teaching or Sarah's teaching, the same thing. And then either one of the other helpers will answer in the chat, or if they think it's a question that one of the instructors should actually just stop and address, then they can take themselves off mute and interrupt and say, hey, answer this question from so-and-so. We'll take a 15-minute break at about 3:15 and another one at about 4:45 this afternoon, just to break up the 4 hours a little bit. And basically everything you need, as Rex said, is in that materials tab in GoToTraining. That has the link to the download instructions, to the lesson notes we'll be working from, and to the workshop website that has the schedule and all the other details about the workshop. So yeah, that's basically how the format will run for this first 2 days. Any burning questions anyone has before we jump in and actually start talking Python? No? Cool.
There's a question here. There's a question from Greta asking, can someone refresh where the materials tab is at? Maybe if you shared your screen and showed her what that panel looks like with the materials that's underneath the webcam controls.
Yeah, thanks, Scott. Unfortunately, I can't share what the actual GoToTraining looks like.
Well,
I can offer a brief bit of advice. If someone is using a PC, on the top of the control panel, there's a View button. It's next to File Options, and then there's View. And if you click on that, you should be able to return your control panel to the default layout. And you can also confirm there if the materials panel is showing there should be a check mark next to it in the list of different panels that are available. Anyone should be able to find it there. If not, please follow up with me privately and I can try to see what's going on. However, that should be its location.
Cool. Thanks, Rex. No other questions have come up, so I might share my web browser and we'll jump in. There we go. So hopefully you're now seeing my web browser here. And so the first lesson is really just on Python package management. And so before we kind of jump in and start figuring out how we're going to plot that precipitation climatology, we need to start to think about, well, what Python libraries are we going to use to do this? And so here's a bit of a sketch here of what I call the PyAOS, the Python in Atmosphere and Ocean Science stack, the kind of collection of libraries that commonly get used in Atmosphere and Ocean Science with Python. And so in this dotted box here is basically what I call the core libraries. And so depending on how much Python you've done in Atmosphere and Ocean Science, you'll be familiar with a lot of the names of these libraries. But there's a netcdf4 library for reading and writing netcdf files, which is obviously something we do quite a lot. There's a NumPy numerical Python library for dealing with numerical arrays, which is obviously something we do a lot of. There's a SciPy library, a scientific Python library with a whole bunch of kind of mathematical routines for acting on those numerical arrays. And so, for instance, here's the SciPy website here. There's functions for integration, optimization, interpolation, Fourier transforms, linear algebra, all sorts of stuff. So a real treasure trove of routines that you'll commonly use when doing data analysis. Then there's a library called Dask, which helps with parallel processing. So for tasks where you've got really big data and you want to distribute your data processing to multiple cores on your machine, or you want to avoid memory errors when you're trying to read in large amounts of data. And we'll be working with Dask probably on Thursday afternoon. There's the matplotlib library, which many of you will probably be familiar with. It's called that because it's a copy of the MATLAB plotting library written in Python. And so you're possibly familiar with the matplotlib gallery, which has, basically every type of static plot you could think of. If you're doing static plotting, you're probably going to be using matplotlib in Python. CartoPy is a good one, particularly for people in atmosphere and ocean science, which helps with geographic map projections. So here's the CartoPy projection list. So from pretty standard map projections to pretty funky map projections, it really helps. If you're using matplotlib, you can use CartoPy as well to help with whatever map projection you're after. And lastly, in this kind of core stack is a library called Bokeh. And now that we're getting into this kind of world where we're doing interactive plots, not just static plots. So here's an interactive Bokeh plot where you can hover over values. You can, if I click it, you can zoom in on certain parts of a plot and all sorts of things like that. So that's kind of the last piece here in this, what I'd describe as the core stack. And you can do everything that you'd want to do basically with those libraries. They're very powerful, but oftentimes it can take quite a bit of, quite a lot of lines of code. And so what people do is that they come along and they build on top of these libraries to make particular tasks easier. And so two main ones, I guess, in our area are xray and iris, which are built on top of a lot of these core libraries to make common things that atmosphere and ocean science people do easier. So for instance, if you're reading in a netcdf file, if you want to also read in the metadata in that file, normally that's some multiple lines of code to first read in the data into a NumPy array and then read in the metadata. We do that so commonly, it'd be nice if you could just do that in one line. And so that's what xray and iris offer. They've basically taken that functionality out of netcdf4 and made it so in one line you can get the data and the metadata, for instance. So it's more efficient. And then people have then built on top of xray and iris again. So there's a library, for instance, called GeoViews for quickly kind of exploring geographic data. Some of the libraries we're doing later in this workshop, like MetPy and PyArt and things, built on top of xray and stuff as well. And so basically, I guess the moral of the story is a lot of the time, if you're looking to do something in Python, it's worth being aware of the core libraries, but also on the lookout for libraries that are built on top of those to make things easier. And by easier, I typically mean less lines of code. Yeah, I guess that's the general principle. And so now that we've kind of identified that we might want to be using, we'll be using xray in this workshop and a few of these core libraries as well. How do we actually go about installing those on our machine? And hopefully a lot of you have kind of done that in preparation for this workshop using Anaconda. But to give you a bit of background, basically your first impulse when installing a Python library might be use what's called pip, the Python package installer. But the problem with that is that, particularly for data science, is that it's only really useful for installing packages written purely in Python. And a lot of our data science libraries have C dependencies or Fortran dependencies and tricky things like that. And it can be a bit of a nightmare to install all those dependencies. So what people have done is they put together what are called Python distributions, where they basically, they come with a whole bunch of popular libraries already pre-installed with all their dependencies as well. And so Anaconda is the most, I guess, popular data science distribution today. And it comes with about 250 or so of the most common data science libraries and their dependencies already pre-installed, so you don't have to do it. And it also comes with a package manager called Conda, which helps you install other libraries that weren't pre-installed. And so there's a few thousand extra libraries that Anaconda basically guarantees will work when you run Conda install. And so it's been a game changer really for data science. And so to give you a bit of an idea of what that looks like, if I share my screen again, and if I head back to I'm cheating here. I should, we'll come back to that in a minute. Oops. So if I start at my command line here, let's say I want to install xray. That's a library that we're interested in. That's one of the libraries that's not one of the 250 that come already pre-installed with Anaconda, but it is one of the few thousand that Anaconda guarantees will work if you type condor install. So I could simply just type condor install xray, and it'll go away and have a bit of a think about what all the dependencies are and what all the things it would need to do in order to install that library. And then it'll come back to me and tell me whether it can install that for me. And while it's having a think, that's one way I could install xray. The other way is using the Anaconda navigator. And so if you've played around with the Anaconda navigator that you will have installed for this workshop, you can go to the and in our base environment, I could search for xray in the not installed libraries, and I could select it from the list here and install it that way. So I could select it and then click apply, and it would install xray into my base environment here in the Anaconda navigator. So either way, whether you're comfortable using the navigator or whether you're using the command line, and here I'll say no here, but that's basically how it works. So that's all well and good. xray was an easy one for us because it's part of the 1,000 or so libraries that are supported by Anaconda. What if we're looking at a more niche library that isn't supported by Anaconda? What if, say, for instance, we're interested in the iris library, which is written by the Met Office, and it is a little more niche. It's not a general purpose library for multidimensional data like xray. It's really just for people working in climate science, and so it's not on the list of the few thousand that Anaconda supports. What do we do? And the good thing is, the really good thing about Anaconda is this website called anaconda.org, where basically if you're the developer of a library that is a bit niche and isn't going to be supported by Anaconda, you can post some recipes up on this site that people can use to install them using Conda. And so I could search anaconda.org for the iris library, and here's all these recipes that people have posted that can be used to install iris. And so that's good. But a little bit of the problem is there's so many here, like SciTools, which is the project that runs iris, has posted a recipe. The International Ocean Observing System has posted a recipe. Like, which one do I use? And so to get around that problem, recently there's a site called Condor Forge, and I should have brought this one up, which basically aims to be the place where the one kind of working recipe for each Conda library exists. So what we can basically do is we can tell Anaconda that, as well as looking in the repository of the 1,000 or so libraries that are supported by Anaconda automatically, we can add a channel. And so I could go conda config, and then I can add a channel, and that channel I can call Condor Forge. Oh, that doesn't work anymore. I'll look up how to do that, but in the meantime, you can also do it at the Anaconda Navigator. You can go channels, and I've already got Condor Forge added here, but if I didn't, I could type in Condor Forge and add it that way. So that helps me. Cancel. That means that when we type condor install, it will search both the 1,000 or so supported libraries, and then if it's not available there, it will search Condor Forge. And so if I did condor install Iris, it would go ahead and think about, it will end up finding the recipe for Iris on Condor Forge.
And just a heads up, everyone should be keeping an eye on the chat. Rita has obviously been doing their homework, because apparently it's double dash and.
Oh, thank you. Thank you. That's a good tip. Cool. So in terms of then the software installation for these particular lessons, and we got you to do that ahead of time just to save a bit of time, but you will have noticed that if I kill this while it's searching, you will have seen that in the software installation instructions, we had you condor install a bunch of libraries. So if I remember correctly, it was xray for that general data processing. It was Dask because we're going to be learning about dealing with big data arrays later on. It was netcdf4 because xray uses that to access netcdf files. It was cartopy, so we can use all those lovely map projections that we're interested in. CMOcean was another one on there, which is a great library that has a bunch of color palettes that are used in kind of mainly in plotting oceanographic data, but it also turns out that, like we'll see later on, that the ocean salinity color palettes are also pretty good for rainfall. And then there was one called Command Line Provenance, which is basically for keeping track of our data processing steps. And so I won't run that because I've already installed them, but that's basically all the libraries that we're installing for this workshop. And you will have noticed in the software setup instructions that if you are basically fairly new to Anaconda, it said just install them straight into your base environment. Or if you were if you were a bit experienced in Anaconda, it said, well, you may wish to install them in a new separate environment. And so you could go condor create and then give a name for a new environment that I think we called PyIOS lesson, and then list, xray, Dask, etc., etc. And so that was another option in the installation instructions. And often it can be very nice to keep your different Python environments separate. And so you can imagine a situation where you're working on, say, 2 different papers and you're using slightly different software versions and things for each paper. It might be good to have a separate Python environment for each of those papers. Or you might be doing something completely different. You might be, I don't know, developing a website with Python as well as doing data analysis, and it might be good to have all your website related libraries in one environment and all your data science ones in another one. And so I've gone ahead and installed that environment. So I can go condor activate PyIOS lesson. My prompt changed to tell me that I'm no longer in the base environment. I'm now in the PyIOS lesson environment. And so that's what I'll be doing. And it really doesn't matter whether for this lesson whether you're using the base or whether you did create the PyIOS lesson environment. Either is fine. One of the nice things about these environments, though, is that you can export them. So, for instance, I can Condor has a command for exporting environments. So condor env export, and then I tell it the name of the lesson I'd like to export, and then the name of the file I'd like to export it to. And so if I ran that, and then if I concatenate this new environment file to have a look what's in there, we can see that it's a list of every single library and its version number that's installed in this PyOS lesson environment. And it tells you where it got it from. It got them from the defaults channel, which has the 1,000 or so supported libraries, and also Condor Forge, which was that website where people can post recipes for more niche libraries. And so basically, if you wanted someone to have your exact environment, you can send them that environment file, and then they can type at their command line. Let me just remember what that is. Yeah, they can just go condor env create, the name of the environment file, and it would install that exact environment, all those libraries on their computer. So it's a real great way for kind of reproducible science and things like that, that you can export your Python environment and have someone else, or Condor environment, and have someone else install basically the same thing down to the exact same version numbers on their computer, which is a pretty cool thing. So I need to stop talking pretty soon and let you guys have a play around yourselves. So the last thing basically we need to do before you guys jump into the exercises is figure out now, we've figured out what libraries we want to use, we've figured out how to install them. The last thing is, well, how are we going to interact with Python when we're starting to figure out how we're going to do this data analysis task of plotting the rainfall climatology. So obviously the simplest way to interact with Python is just a command line session. Just typing Python at the command line. We could do all the things you would normally do in a lesson, but that's obviously a very basic Python experience. And so I guess the next way we could interact with Python is using IPython, interactive Python, rather than just regular Python. And it's basically a smarter command line experience with Python, as well as doing things like printing hello world. You can see it has syntax highlighting, which makes the code a little bit easier to interpret. And we can also do cool things like we can use a shell command, like the ls for listing the things that are in my current directory. That's not a Python command, but it's smart enough to realize that I'm at the command line here. If I type ls, I probably mean the shell command ls, and it shows me the files in my current directory. So it's kind of like a smarter Python experience, but it's still kind of at the command line, and you have to type the commands line by line, which is a bit cumbersome if you're doing code development. And so what most people do when they're working with Python, trying to figure out a new problem and how to do it, is they'll use either an interactive development environment, an IDE, or they'll use the Jupyter Notebook. And so if any of you have ever used an IDE before, here, for example, is what Spider looks like, which comes with Anaconda. And so it's a very kind of like MATLAB type experience. So you've got your script over here on the window, you've got the IPython interpreter there, you've got a console up here that shows you what all variables are defined and things like that. So a very kind of RStudio MATLAB type experience. Or people also use the Jupyter Notebook. And if I run a Jupyter Notebook here to show you what that means. So I can start a new Python 3 notebook. And here we are here with our notebook, and we can type basically code into these blocks. So we can do all the things we did before. Oops. Complete with a typo. And then I can hold down Shift and Return when I want to execute all the code in a cell like this. So I could import xray as xr, import numerical Python as np, and so on. And when I'm done, hit Shift and Return, and it'll load those libraries. And so, yeah, people normally either kind of when they're messing around with a problem trying to figure it out, they'll either use a Jupyter Notebook, which is what we'll use for this workshop, or an interactive development environment like Spider or PyCharm or something like that. So that's basically the end of my little crash course into Python libraries and package management and things like that. And so we'll break off into breakout rooms in a minute. And what I'll get you to do is head to the lessons page. Oops, not that lesson. Where are we? So in the materials tab, there's the lessons link, and you'll end up with a page like this. And down here is every lesson that we're doing throughout the workshop. So if you click on the package management one, there's basically a more detailed account of everything I just said, complete with screenshots, basically. And then if you scroll to the bottom, there's these orange boxes which have the challenges to work on in the breakout rooms. And so for this one, the first challenge is to install the libraries if you haven't already, and then to launch a Jupyter notebook and to import a few of the libraries we're going to be using. So that's basically the first challenge, is just to get set up with your Jupyter notebook open, ready to go. And so I might get Rex, I'll stop sharing my screen, and I might get Rex to break us out into breakout groups.
All right. So, hi everyone, I'm Sarah. I am a PhD candidate at Washington State University. I have been working in Python for like 6 years, maybe. I do some wharf modeling, not in Python, but my research is around wharf modeling in polar regions. Just to give you a little information about me. So for this section, we are going to be looking at functions. And so we've been using functions that are part of like libraries that have already been made at this point, but we want to start using functions that we've created. And so what we're going to do is we're going to make a function using the script that we just wrote with Kathy and edited on our own. So I just have a copy of that here. And so what I'm going to do is I'm going to take this and I'm going to turn this into a function. So we could give this script to someone else and say the way that you make a figure, you use a script. And so it will have all the documentation they'll need to know how to make the figure. You might, I was muted very briefly. Okay. You might say, why would we not just copy and paste this? Why would we go through the effort of going into more complicated coding? And it's really more robust for us to make this into a function, because if we just copied and pasted this and we're editing it for different data sets, or like if we wanted a figure of just a subset of the data, then we could mess up anything from the path or like the labeling, something like that. So when we make a function, we really make sure that what we're doing is consistent throughout every time we create a figure with this. Additionally, it's good for repeating our work if we want to recreate a figure that, say, we made for a presentation a while ago, but we lost like that actual file. We can also use it for that. So I just want to remind you before I start actually coding that the lesson is on that website that has been sent in the chat. And so I am going to start with just copy and pasting the same plot that we used in the previous lesson. If you have a working plot from the previous lesson, you can copy and paste what you made, or you can copy and paste from the lessons, or you don't have to follow along at all, but that's if you just want to. So this is just that same script here. And I'm just going to run it to make sure that everything is set up for this code to run, so I know that none of this code is going to be giving me an error. So I'm just holding Shift and hitting Enter, which is a shortcut to run these cells, and we see that we get this again. And so we have the title, and we have the changed CMAP here, because this is after our exercises. And again, if you go to this page, this page, which is the functions lesson page, this code here, this is what I'm using. So I'm going to take this away now and go back to this. Okay, so I'm going to start in this empty cell and I'm going to define my function. So in order to do this, I'm going to type DEF, And so you'll notice that that turns green. So we know that Python recognizes that we are defining something. And so now I want to name my function, and I want to name it something that makes sense because we're going to be using this name a lot when we call this function in the future. So I'm going to call it plot underscore PR underscore climatology. And then I'm going to put parentheses here. And so this is where I'm going to define what arguments the user can input into this function. So I want the user to be able to input whatever file they want. So I'm going to say PR file as the variable for that. I want the user to input the season they want. So what my goal with this figure is that I want the user to be able to put in like June, July, August, or whatever subset of whatever season subset they want. So I'm just going to write season here so that the user can put that in. And then lastly, I'm going to let the user define if they want grid points. So or grid lines, I mean. So I'm going to write grid lines. And then I am going to write equals false. And so I am setting grid lines equal to something and nothing else equal to something because I want this argument to have a default. So you might have noticed, or maybe you haven't, but in programming in Python, sometimes if you don't put on an argument, there's a default that Python knows to use. And so that's what we're doing by using the equal sign here. We're just denoting that that's our default. These two don't have equal signs, so the user will need to put in your PR file and season. So now that we've defined our function, we're going to put a colon there and we're going to hit enter. And you'll notice that when you do this, that it indents you one tab or right underneath your plot PR climatology. And so we want to make sure that we keep this indented because Python is very sensitive to indentation. So it knows that if it's indented, it's part of this function. So first I want to add some documentation so that the person who's using this function, if it's not me, knows what to do, or even if it's me in the future. So to do this, I'm going to create a doc string. And so to create this, I'm just going to do 3 quotation marks. And you'll notice that Python will automatically give you 3 more quotation marks, and that's what we want. And then I'm just going to hit enter twice. And so what this is doing is just defining an area that I can type notes in that aren't going to be rendered as code. The Python won't even look at this when it's running. So I'm going to first say what this code does. So it plots the precipitation climatology. So I'm just going to write that. And so next, I want to be able to tell the user how to define each of these. So if this says PR file and season, I might write fall for season or something like that without having more documentation to really lead me to know how to import these. So I'm going to write args, and then I'm just going to make a list of arguments. You'll notice that I indented here, and because it's in the doc string, it doesn't matter. Python doesn't think that this is a code because it's all within that commented doc string. So first I'm going to write PR file. And for a PR file, I want a string. So I'm going to write str, and then I'm just going to say that this is my precipitation data file. Maybe I should spell precipitation correctly. Okay, so then I will say season, as that's our next argument. And for this, I also want a string. And so I'm going to say season, but then I'm going to say 3-letter abbreviation. For example, JJA for June, July, August. So this will help our user know exactly how to input this information. And then lastly, we have the grid lines. And so this is a Boolean. I'm going to write bool, if I can spell it correctly. And so what that means is that it is going to be true or false. So this selects whether to plot grid lines. Okay, so this is the completion of our doc string. So I'm just gonna get out of the doc string and start typing below it. Notice that I'm still tabbed in, so we're still part of this function. So I'm gonna scroll up now, and I'm just gonna grab this code, and we're gonna edit this code to be better suited to our function. So I'm just gonna copy this and paste it down here. And so you'll notice that it doesn't automatically tab in all of this. So I'm just going to go in and tab it in so that it knows that it's part of the function. Okay. So now we need to go in and change some of these variables so that they are looking for the user input variables and not what we've coded into here. So the first thing that I'm going to do is change the data set. And so to do this, I'm going to get rid of this line because this line is just defining that string, and that's what I want the user to do. So I'm just going to delete that. And then I'm going to put PR file here so that when we do the open dataset command, we are opening the dataset we have under PR file. So now let's go down. We have this selected by season. So this is great. This is what we want. And then just want to make sure I'm not forgetting anything. Come down here. Okay, so we want all of our code to be the same except for the grid lines. So we're going to add an if statement here. So below coastlines, I'm going to type if, and that's going to turn green again. And so this is the same with how we defined our function. When we write loops, Python also recognizes it and will turn it green. And so I'm just going to say if grid lines and then hit enter. And so grid lines, if you remember up here, is a Boolean. And so if we say grid lines is false, or if we don't say anything, this will go through here and check this and see if grid lines is false. We won't go through the loop. But if we've set grid lines to be true, it will say grid lines is true, it will go through this loop. So we hit enter, it automatically tabs in, and I'm just gonna do plt.gca parentheses dot grid lines. And so all this does is it just modifies our plot and gives it grid lines. And then lastly, I want to change the title because we see that we have June, July, August hard programmed in here. And so I just want, I want Python to know what we've selected. So in curly brackets, I'm going to type season because that's where we put in our string of June, July, August, or whatever we want. And then we have the title, and we can run that. So if you've been following along and you ran that, you might notice that nothing happened. And that's okay, that's what we want. When we run this, all it's doing is storing our function into Python, so it's now in the memory, but it's not actually doing these commands because it doesn't know what file to grab from, it doesn't know what season, it does know what to do with grid lines, but we haven't input any of that information yet. So now this is just some code that Python remembers. So first, let's look at our documentation for this code. If we were someone new looking at this, we might want to know how to use it. So we could say help, plot, PR, climatology, and we get this information. And so hopefully this looks familiar because right here is, this is the command you would use to actually use this function, but this is also our name and then our arguments that we just defined above. And then we have the description that we put in, and then this argument section that I typed in earlier. So this is all just what we typed into that comment section. So this is how somebody could read it if they weren't working in the script that you had all of this written on. So now let's try and run this. Let's try and make a figure with this. So
hey Sarah, just a quick one. A hawk-eyed audience member spotted a hard-coded JJA in your function.
Oh, yes, you're right. Thank you for catching that. So we want to add season here so that it knows that the season it's looking at is the June, July, August, or whatever season the person put in up here. That was a good catch. If I hadn't changed that, then no matter what I ran, it would have been June, July, August, but it would have changed the season in the title. And this is one of the advantages to writing a function like this is that, well, I guess the advantage is not that if you mess up, it's messed up on all of them, but that if you do it correctly once, you won't have those mess ups kind of permeate into other things. So I'm going to rerun this because I changed something. And so I want to restore it in the memory. And so now we are going to run it. So I'm going to say plot underscore PR underscore climatology. And then parentheses. So this is where I'm going to put my function. And I'm going to scroll up and copy the path that we used with Kathy, just because I don't want to type that all out. So we come down here. I'm going to put this here in quotations because it's a string. And then we want to put JJA for June, July, August. And I'm not going to define a grid line thing here. You might notice that after the comma, I hit enter and am down here. You don't need to do this. I just did it because my font is large and I wanted you to be able to see everything. So now I'm going to run this. And I have a figure. And it has changed, hopefully. Now, to make sure that I don't have anything hardwired in here, I want to do this again, but I'm going to pick a different month just to make sure. So I'm just copying and pasting this down, and then I'm going to say December, January, February. And I'll run it, and we see that we have this figure, and it is indeed different from this other figure. So we must have done something right. So now we can try adding grid lines. So I'm just going to say grid lines equals true here, and then run this. And we see that it gives us grid lines. We could also just write true here. Just like with the other ones, we can just write our what we want for that. But I like to put the argument here. So yeah, we have that. So now, I guess I want to take any questions about functions that you have, and then we're going to go into breakout rooms and do an exercise with functions. So I'm going to figure how to pull up the chat.
You've got a
yes.
You got a specific question in the chat just there from Yung Yang An.
Okay. If grid lines. Yeah, so the question is about the if grid lines statement, this loop here. And so yeah, this is kind of a new thing that we haven't seen yet, doing the loops, but because this is a Boolean, so because this is true or false, we can use it to say like if, and then if true, it will continue. If false, it will not continue. And because we've set a default, if false, we're using false. This is a confusing way to word this, I feel like.
That's a very Python-y thing, and folks who might be moving from different programming languages, such as IDL and so forth, that are a lot more explicit, for lack of better words, will notice Python can be very flexible in the way it does things like binaries and spanning across loops. So, but yes, Booleans can be used very flexibly in very interesting ways.
Yeah, that's a great question.
To jump in here real quick, I think the question was nothing is defined as grid lines. So grid lines is one of the arguments coming into the function here when you call it. And so when we call the function, we give it up to 3 arguments: PR, file, season, and grid lines. Now, because grid lines has that equals false there, what that means is it has a default value of false. And so you can call the function with 2 arguments, and Python will helpfully fill in the third for you with the default value there of false. So that's where grid lines, when you call the function, that's where it's defined.
Thank you, yes. Yeah, I'm just reading up through the chat now. If anyone has any more questions, they can put those in there. It looks like grid lines are defined in GCA of PLT. Yeah, so that GCA of PLT is just something that handles some of the display and customization. I don't know exactly what GCA stands for. Maybe somebody else does, but that is just sometimes how you customize your plot by using GCA of PLT.
So I'll jump in here. GCA stands for get current axes. And so that's a function in Matplotlib that gets the current axes. To be clear, not axis, which would be one side of a plot, but axes, which is the whole thing you're drawing on. And so that says get the current axes that we're drawing on, and then turn on the grid lines on it.
Very, very useful. And by the way, you'll get the latest one you've created. The other interesting one to use is plt.gcf, which is get current figure as well.
Awesome, thank you. Someone asked if we can do plt.grid instead of plt.gca.gridlines. And I believe we can. I am not positive about that. But
no, unfortunately, Cartopy uses a separate thing to manage its grid lines than the grid, and that has to do with details of working with map projections where your grid lines aren't necessarily straight lines.
Okay, awesome. Thank you. So we had a question about if it is bad to have the variable name inside the function and outside the function with the same name, or if they're completely isolated. And yeah, so this is something that I didn't go over, but maybe I should have. Any variables defined outside of the function, I think the variables outside will go into the function, but the variables inside the function will not go out of the function. So like I couldn't refer to these variables, but for general best practice, you should try and keep your variable names different just so that you don't get confused and nothing is like inadvertently overwriting something else. So I would recommend you not do that in general, just to make sure that nothing happens that you're not planning.
If I could clarify one thing there, it depends on if it's your, there are keywords where you can get that behavior if you want to write to a variable that's not defined in your function. By default, you can read. So anything that's defined outside your function in a higher level that kind of encloses that function, you can get to and read. Modifying those values, you have to use some separate keywords that I'm not even going to mention because I would strongly encourage you not to write functions that try to modify state outside the function you're running, but instead return those as values and things. So the answer is, confusingly, it depends.
All right, thank you.
I think
Someone
I saw some
asked,
questions in the chat about earlier that kind of scrolled by about how to use the .cell to select the season. Maybe you could explain that a little bit.
Yeah, okay. So .cell stands for .select. And so where is it here? So what this is saying is it's selecting the climate data, and then we're just defining the season to be season, which is a little confusing because we have season used twice here. But this season is what we have defined up here. And then this season is a characteristic within the climate data set. So that's why these are the same word, but they are referring to different things. That's why we would say season equals season, because we are setting the season variable to be what we've set as season, if that makes sense. So we're saying basically season equals, and then you can imagine that this is that JJA string or something like that to select it. Does that answer the question? I don't know if that answered the question entirely. Okay.
Sarah, I'm happy to start breakout rooms whenever you feel you're ready for it.
Yeah, there are just a lot of questions, and I am not sure of a lot of the plotting ones. So if you have plotting questions, maybe best to direct those to Kathy, or we can talk about those more, I don't know. But I am more in the function side. And then someone said they didn't see the season variable in the metadata of the file. So could someone help me out here with what this season is referring to if it's not in the file?
Yeah, so we created seasons when you did the group by time.season. And if you print out climb, you'll see that season is now one of the dimensions of the climb variable.
Thank you, Kathy. Okay, so why don't we go into the breakout rooms now? The exercise that you will do, I have written here, but you also have it on the on that web page, and I think you'll be able to see this then, but I would recommend you pull up the web page for that. And so what we're doing is just editing this function that we created to be shorter and a little easier to read by creating a couple more functions that we're going to be using within it. So we will be defining convert PR units, convert or create plot, and then the plot PR climatology function is the one we already have. So we're just defining these two new functions. So yeah, we can do the breakout rooms now if you're ready for that, Rex.
Just give me a minute or two. I'm currently getting the instructors in the right rooms.
Oh, yeah, no worries. I just didn't want you to be waiting on me to say something.
Of course. Feel free to banter for just a couple minutes.
I'm not the best person to banter. But I'll talk a little bit more about the short function thing briefly, the exercise. You'll see on the page that you have this little snippet of code, and this is the code that should ultimately run when you've written these other functions. And after this, I'll have a little bit when we come back together, I will have one more thing to just note about this, and then we can move on to the next topic. What I've done is I copied the solution from the exercises that we just did, and I pasted it into its own Python script. And so you don't necessarily need to follow along with this. I'm just going to show you this briefly, but these are those functions that you just created, and I saved them in a Python script that I've called unit conversion. So now if I want to import unit conversion into my script so that I can use convert PR units, create plot, and so on, all I have to do is type import unit conversion. And so we see that we didn't get an error here, so we know that it imported. And to see that this has everything that we need in it, we can just type help. And here are all our functions and the ways that we would use them, just like what we saw when we had written the function within the within our notebook. And then we would use this just like we would use anything else, unit conversion, dot, and then we could use any of our functions. And so that is all I have for the functions lesson. I believe Damien's going to do the command line now. Okay, and so
Cool. Thanks, Sarah. Hopefully people can see my screen.
Hey, Damien, I'm just going to mute everyone else for a sec. Hang on just one moment.
Cool.
All right. Thanks.
Cool. So everyone can see my screen?
I can. Yep.
Cool.
Yes.
Cool. Yeah, so just for the last 5 minutes, I was going to basically go through the next command line programs lesson and then basically leave the exercises for that for homework before the next lesson. And so we've basically spent the afternoon scoping out how to do this problem. We want to be able to plot the precipitation climatology for CMIP6 data files that we've got. We've kind of scoped it out. We've got an idea. Now we can successfully create the plot. Oftentimes what you'll do at that point is then you'll transfer the code that you've scoped out and developed from a notebook that you've been scoping things out in into a script that can be run at the command line. And you don't have to do that, but there are lots of kind of good reasons to do it. One is, for instance, you might have a data workflow that involves some command line tools. And so you might be using, if anyone's used CDO, the climate data operators, you might have a workflow that uses a CDO command to do something to a netcdf file. And then the next step in the process is your Python code that you've written. And so you can coordinate all this from the command line if you can make your Python code executable from the command line, like a CDO command, like an NCO command, netcdf operators, or any other command line tools you're using. And so that's what this lesson's about, taking code that you've got working and converting it into a script that can be run at the command line like any other command line program. And so this is a script template you will have seen in the files that you were going to download, that you downloaded before the workshop. There was a script_template.py. And I've just opened it with my favorite text editor here. I'm using BB Edit. You might be using whatever text editor that you like to use. But this is kind of a typical structure of a script. And if I start at the bottom, there's normally this cryptic thing that you'll see in a lot of Python scripts that says if _name equals _main, do a bunch of stuff. And what that is basically asking is, was this script run at the command line? Because there's obviously two ways to use a Python script. You can either execute them at the command line, or you can import them like Sarah just imported the unit conversion script. And so in the case that Sarah had where she imported it, in the background, this name variable was set to the name of that script. It was set to unit conversion. Whereas if you execute a script at the command line, name is set to this value called main. And so you're basically asking the question here, if this was executed at the command line, not imported as a library, then do whatever's here. And often what you'll do is you'll use the argpars library, which is, as the name suggests, a library for parsing the arguments that were entered at the command line. So basically define the inputs that the user is supposed to enter at the command line. And so here we're using it to, well, first we've described like a description of what the program does, and then we've just defined 2 arguments in this script template. We're expecting the person to give the name of an input file and the name of an output file, which is obviously a common thing that would happen with Python scripts. You might read in a netcdf file, the script then manipulates it and then outputs a new netcdf file. And then we, once we've made all those definitions, we set them to a variable called args, and we pass that args variable to a function called, kind of traditionally, is the function that describes what it is that the script does, the main thing that the script does. And so you'll end up with this kind of structure where you import your libraries at the top, then you define all the functions that get used by main to do the main thing that this script does, and then you define main, which uses all those other functions, and then you have the bit at the bottom that parses the command line if this has been run as a command line script. And so to see this in action, if I went to execute a script at the command line, you just type Python and then the name of the script. So in this case, Python and then script template. And because argpars is very smart and it can format help information for us. So if I use the -h option, like is available on most command line programs, it should give me some informative help information about this program. And it does. It gives me the description that we defined. It tells me which arguments it's expecting from the user. And it tells me what optional arguments exist, which at the moment is the help. And so argpars is really helping us write Python scripts that act and feel and look just like every other command line program. And so if I ran this now, script template, and I had an input file called in.nc and an output file called out.nc, it should print those to the screen. And so it's working. And so what we've basically done to save you the time and effort is take all those functions we've just been developing in the last lesson, and we've dumped them in a script called plotprecipitation.py, which you downloaded at the beginning of the workshop. And you can see that in putting this script together, we've followed that script template. So we've started by importing all the libraries that we've been using. And then these functions will look familiar to you. Here's our convert precipitation units function. Here's our create plot function. And then we have this function called main, which does the main thing that this script does. Reads in the data set, calculates the climatology, creates the plot, saves the figure to the file. And then at the bottom of this plot precipitation climatology script that you've got, it's used argpars to define the 3 arguments that we want the user to enter at the command line. And so those are similar to the function we wrote earlier, the precipitation data file, a particular season, and then the name of the output, like PNG file that we want this script to produce. And so over the course of the workshop, we'll be making edits and improvements and stuff to this plot precipitation climatology script, but to kind of get you started, we've used the template and put all the functions in there for you. And so I should be able to run this script at the command line and get that plot that we were just plotting in our notebook. So I should be able to type Python plot precipitation climatology, and then I've already forgotten what arguments it expects, so I can use the -h option, and it'll hopefully tell me after a bit of a think. Here we go. So it wants the precipitation file, then the season, then the output file. So the precipitation file data. Let's do the access ESM data file this time. Let's do September, October, November, and let's call it sonplot.png. So if I run that, and then check my directory, there we go. There's the plot for Access ESM for the September, October, November season. Cool. So that's basically our starting point, and then the homework for you in the command line programs lesson is at the bottom of the lesson here is basically getting you to find out basically a lot of the really cool features that argpars has. So we can make argpars, we can define some choices for the season. And so if people don't enter DJF, MAM, JJA, or SON, it'll give an informative error message saying, that's not a valid season you've entered, these are the valid seasons. Or we can have an option at the command line for doing grid lines. And we can set the color bar levels and lots of things like that. So basically the challenge for you basically between now and the next lesson is just to have a go at taking that initial plot precipitation climatology script and just make some of these changes to start getting a feel for the argpars library and the really cool things you can do with it. So that's probably all I've got to share on that. I can probably stop sharing my, well, I should look in the chat. Yeah, any questions anyone's got in the chat before we kind of wrap up for the day? No, I'll stop my sharing for now. There we go. Oh, someone's just asked if I can go to the command line. Sure.
I see a couple hands raised as well from two people, Angela and Shimao.
Yeah, feel free to take yourself off mute and ask a question if you've got one.
Sure, I've just allowed everyone to come off of mute if they wish.
Any questions anyone's got? Can I go to the command line? Yeah, sorry. Go ahead.
Yeah, so you're not sharing your screen anymore. So I think the question is asking to show us how you get to the command line and terminal. And since we can't see your screen, we can't see.
Oh, no problem. Yeah, so I'm on a Mac, and so I went to the terminal program, and that got me there. Which, if you're on a Windows machine, you will have installed Git Bash, which is so the native shell environment on a Windows machine is Windows PowerShell, which is not what we want. We want a bash shell like I've been using. So Git Bash provides that. It's called a terminal emulator, and it gives you a bash environment on your Windows machine. So search for Git Bash if you're on a Windows machine, or search for the terminal app if you're on a Mac. What about making the Python script executable without needing to invoke Python? Yeah, you can, and some of the other Pythonista instructors might know this better than me, but you can put, I think you can put a line at the top of your script, is it called a shebang or something, to make it so that you don't have to type Python and the name of the script, you can just type the name of the script. I tend to just type Python just because it kind of reminds me that I'm running a Python script as opposed to some other type. But yeah, there are ways to avoid that if you want to.
Damien, one thing I wanted to jump in there real quick is, in addition to the shebang line, as we call it, the other part is you have to, depending on your operating system, have to set the script to executable, which you can do on the Unix-like operating systems, Mac and Linux. but I don't know how you go about doing that on the Windows side.
Yeah, cool, thanks. Thanks, Ryan. Yeah, so in general, typing Python might be a little simpler than figuring out those solutions. Do I create a Python script in Git Bash? No, you can basically use whatever text editor you like to create your Python script. So you will have seen that I used, where are we here? BBEdit is the text editor that I used, and a lot of the text editors, if you save a file and you end it in the extension .py, they'll know that you're using that you're writing Python code, and they'll do the syntax highlighting. So this is highlighting keywords like import and def and things like that, because it knows that I'm writing a Python script. But there are lots of other, I mean, Jupyter itself has its own kind of like text editor. So you can just click on a file in the Jupyter menu here, and it'll open a text editor that you can use. So you can use the text editor that comes with Jupyter if you like. You can use, yeah, some people like being at the command line and using VI as their editor, which is basically just like, so if I went to VI, precipitation climatology.py, I can now edit the code here like this in the command line. So you can use an editor like that if you want. Really, it's personal preference. Really, everyone kind of has their favorite text editor or their way of doing it.
Shameless plug, 2 years ago at the Python symposiums when we had them in person, we actually had a panel session called Show Me Your Stack. And that's it. That's really the joy of something like Python, is there are so many ways to edit and compose actual functions like command line functions, and you'll find that you'll use a variety of tools, the right tool for the right purpose.
Almost done.
Any other questions before we wrap it up? Yeah, in Jupyter you could save as .py if you want a script. Yep.
Also, a note for anybody who's thinking about learning Git and using GitHub, putting a Jupyter notebook up on GitHub is a great way to share science. GitHub will automatically render Jupyter notebooks.
Yeah, that's a good point. Yeah, so there's text file. So yeah, that's a good segue into Thursday's session, Scott. So for instance, if you're on Thursday, we'll look at putting our code up on GitHub and what you can do. For instance, here's the code I developed for my postdoc. I have like a development folder where I've been messing around in lots of different notebooks, trying to figure things out, and I can view them on GitHub if I want to remember 5 or 10 weeks from now what it is I was messing around with when, in this case, I was working about bin sizes for some binning routine I was writing. So yeah, that's, I guess, a good teaser to get you to come back on Thursday. Cool. Is there a library or site archiving command line Python commands already created? No, I mean, a lot in terms of Python commands, when people make libraries available, like NumPy is available, and you condor install it or whatever, most of the time you'll just be importing from those. But some Python libraries that you install come with command line programs with them. Yeah, that does happen sometimes, but most of the time, when you condor install a library, you'll end up importing its libraries for your own use in scripts that you write for yourself. But there are a handful of libraries that sometimes also provide command line programs that are available once you've condor installed them.